Alright, so this is going to be yet another interesting video, and with this video, we'll discuss Data Lakehouse and OneLake with Microsoft Fabric. So these are two very new and relatively upcoming concepts, and there's utter confusion on the internet. Even there's not much documentation available, and I have had to myself research a lot, and it's my level best attempt. This video is my level best attempt at presenting my research, and hopefully, this is going to clear a lot of things for you as far as Microsoft Fabric is concerned. So let's first of all sort of understand what is a data lakehouse. So the lakehouse architecture was developed to address key challenges that arose with traditional data lake and data warehouse architectures. So there were two architectures. First of all, there was a data warehouse, and then to remove the inconsistencies with data warehouse came data lake, and then to remove these inconsistencies with data lake, in fact, came the lakehouse architecture. And that is what all of these three architectures is what is needed to understand to make yourself more comfortable with Microsoft Fabric. So first of all, to begin with, a data warehouse is a system optimized for storing and querying structured and processed data, primarily for business intelligence and reporting. So a data warehouse included structured data. It did not include or provided a solution to include unstructured as well as semi-structured data. And the limitations of traditional data warehouses were, first of all, there were scalability constraints because you could only store structured data. There were high operation costs, and thirdly, it had limited flexibility. And then to remove these inconsistencies with data warehouses came the concept of data lake. So a data lake is a centralized repository that is designed to store large volumes of raw, unprocessed data in its original format. So with data lake, you could essentially store unstructured as well as semi-structured data. But there were in fact some limitations with traditional data lakes. The limitations were lack of schema enforcement, poor data readability, low query performance, and data governance issues. And also with the growing technology on the AI ML side of things, and also with the growth in unstructured data and demand for real-time analytics, there was an emergence of new data needs. Right? There has to be a solution that could empower your new and emerging data needs. And even if I were to speak up a little bit over here, is even if, let's say, you take the example of ChatGPT, the image generation capability of ChatGPT, that the image generation model of ChatGPT that was built, it was essentially trained on large sets of unstructured data, right? It was trained on large sets of images. And in the same way, if you work with a speech service, something that you could talk with, right? Chatbots that you could talk with, the speech service is also trained on audio, and that audio is unstructured or semi-structured data. And that's why, to cater to your needs of building your AI and ML workloads, there was a growth in unstructured data. And secondly, with the upcoming of IoT devices and near real-time intelligent systems, traditional architectures couldn't support real-time or near real-time analytics on large-scale datasets efficiently. And thirdly, our data lakes are good for raw data storage, but lack the reliability and performance needed for feature engineering, which is pretty much very, very important in building your AI ML workloads and iterative machine learning workflows. Now, this is where Data Lakehouse comes into play. So, Data Lakehouse provides scalable storage and processing capabilities, something that wasn't the case with a data warehouse and a data lake. Uh, for organizations that want to avoid isolated systems, right? You want to avoid data silos for processing different workloads like machine learning and business intelligence. And the whole nature of a data lakehouse is making a solution that serves as your single source of truth for for your organization's data. So going by the textbookist definition of a data lakehouse, well, it's a modern data management architecture. Very clear here that it's an architecture, it's not a product, that combines the best features of data lakes and data warehouses, right? It combines the best of both the worlds. And because it combines the best of both the worlds, it provides the scalability and flexibility of data lakes with the data management and transactional capabilities of a data warehouse, meaning that you can sort of store structured, unstructured, as well as semi-structured data. And then from there, move on to power your BI reports, your BI dashboards, as well as your machine learning and artificial intelligence workloads. So, and the main motive behind this data lakehouse was to establish a single source of truth, eliminating redundant costs, eliminating data silos, and also ensuring data freshness. So, just as I said, data lakehouse is an architecture that's not a product. Now, you might be wondering, what is that product in Azure that rather implements this data lakehouse architecture? And that product is an Azure Data Lake Storage. This ADLS that you see over here, that is an Azure Data Lake Storage. And remember, I talked about data lake having inconsistencies or other disadvantages with schema enforcement, low query performance, and all sorts of things. Now, to remove that disadvantage or other inconsistencies, you have something that's called as a delta lake, and delta lake is suitable for data management features, right? For it implements something that's known as acid, which we'll cover in the upcoming slides. And in that acid, A stands for atomicity, C stands for consistency, I stands for isolation, and D stands for durability. And that acid principle is implemented by delta lake. So, to sum it all, data lakehouse is nothing but a data lake with delta lake integration. And if you see over here in the architecture as well, it's data lake in the underlying, in the very base structure of it, and a delta lake abstraction layer on top of it, which is going to provide it with metadata and governance layer. And as far as this video is concerned, I want you guys to focus on this one and number two that I will point out to you in the slides. And this one is for data lake, and second is a data lake house. And that's what we're going to focus on in this video to understand Microsoft Fabric in a much better manner. So the key features of a data lake house are scalability. So like data lakes, it can store vast amounts of structured, semi-structured and unstructured data. It is a unified platform because it allows for both batch and real-time data processing, making it suitable for a wide range of analytics and machine learning tasks. And because data lakehouse is a combination of data lake with a delta lake integrated layer on top of it, it includes features for data management like asset transactions, schema enforcement, and data versioning, similar to data warehouses, which was the problem with data lake, in fact. So, just as I said, I talked a bit about Delta Lake, which is pretty much responsible for implementing the data lake house architecture. So, and the Delta Lake, the principle that Delta Lake implements for data management is ACID, atomicity, consistency, isolation, and durability. And with this ACID principle, your data becomes your single source of truth for your entire organization. And it opens the room for collaboration. So, because people are going to be working on the same data, it is very essential to establish a single source of truth as far as your organization's data is concerned. So let's come to the A part of ACID. Well, A part of ACID stands here for atomicity. And during a transaction, what atomicity suggests is during a transaction, data files are written to the file directory backing the table. And when the transaction completes, a new entry is committed to the transaction log that includes the path to all files written during the transaction. Now, to help you guys understand what atomicity is better in a better manner, I relate atomicity to my chemistry class in college. So during our first year, we have this very elementary chemistry class that helps us understand the electromechanical model of an atom. And in that chemistry class, they say, well, in an electromechanical model of an atom, you have an orbital that is inside of an atom, and inside of these orbitals can accommodate a maximum of 2 electrons. And inside of these orbitals, one of the electron is in a state that is pointing upwards, which is in a state of +1/2, and is in a state that is pointing downwards. The other one is a state that is pointing downwards, which is denoted by -1/2 in numeric terms. And they tell us that there cannot be any state that sits between the +1/2 state and the -1/2 state. So in essence, an electron at any time can either be pointing upwards or can either be pointing downwards. There's no such state as, in between, as pointing upwards or pointing downwards. It just doesn't exist. And that is what atomicity suggests us. So either you execute a command completely to insert a new record in your table, either that command or query runs completely, or either it fails. right? There is no partial data ingestion taking place inside of a table. And with atomicity, you also implement consistency because the data remains consistent with the query either executing completely or not executing at all. So that's what consistency is all about. And similarly, because with a solution like Fabric that opens the doors for collaboration, be it data engineer, be it a data scientist, an ML engineer, or even a SQL developer, everyone is going to be working on the same data, which is your single source of truth. And because everyone is going to be working on the same data and making periodic writes and updates to the tables that are stored in your storage layer, isolation is very important. And what isolation suggests is the query that these people are going to be executing is going to run into isolation so that one doesn't interfere with the other. And similarly, D, which is durability, it tells that your cloud object, which Fabric uses to store your data, is fault tolerant. And because it is fault tolerant, it has high availability and durability. And you can be rest assured that your data remains consistent throughout, and it would be the same as the one that you saw yesterday and the one that you're going to see tomorrow, provided there were no writes and updates in between. So Delta Lake, all in all, was conceived of as a unified data management system for handling transactional, real-time, and batch big data by extending Parquet data files with a file-based transaction log for asset transactions and scalable metadata handling. And to store all of your files, right, if you work with, let's say, Data Lake or even Data Lakehouse, to store all of your raw data, that raw data is stored in a columnar format. And that columnar format, which first of all lets you run powerful queries in with time constraints and even compress your data a bit because your data is going to be stored in a columnar format. That format is called as a Parquet format. So in the same manner that you use a CSV file, that CSV format is a rows format, whereas Parquet format is a columnar format. So that's the major difference between a CSV and a Parquet format and what exactly your cloud object is going to be using to store your underlying data in its raw form in a data lakehouse. And now let's keep this slide in mind and let's try to understand. Well, hey, we understood what is a data warehouse, what is a data lake, and what is a data lakehouse. Now, how is it related to OneLake or even Fabric as a whole? Let's try to understand this and let's look at the bigger picture with the help of this slide. So your OneLake, which is going to act as the OneDrive for all of your data, right? Just as the way your OneDrive stores your PowerPoint, your Excel workbooks, or even your Word documents. In the same manner, the OneLake, which empowers Fabric, is going to be the OneDrive for all of your data as far as your tenant or an organization as a whole is concerned. And Fabric is a data lake. It's not a data lake house, it's not a data warehouse. Your Fabric OneLake is a data lake. Although the workspaces that you will be creating in Fabric, and by workspaces, I mean place where data scientists, data engineers, ML engineers, SQL developers will be working together. That is called as a workspace. Now, inside of this workspace, you can create a lakehouse and a data warehouse. And when would you create a data lakehouse and data warehouse? That is also pretty important. So whenever you want to store your data in its raw format in Parquet files and then do a bit of manipulation on that raw data before you can publish that raw data as a table, you will use a data lakehouse that's published in a Fabric workspace. And once you have performed data manipulations on your raw data that was stored in data lakehouse, and you want to use that finally published table to build a semantic model that's going to power your Power BI dashboards or reports. And for data reporting, you use a data warehouse because data warehouse has transactional capabilities for powering your BI reports and BI dashboards, right? So again, I'll be repeating OneLake, which is Fabric's OneLake, is a data lake, whereas your in your Fabric workspace, which in your Fabric workspace, which is going to be stored as folders inside of your data lake, because OneLake is your OneDrive for all of your data. Inside of that workspace, you can publish or create a data lakehouse for raw data processing, and then also create a data warehouse for BI reporting and BI intelligence. That's the whole crux of this particular slide. And that is why we learned, first of all of these concepts. And that's how it clubs beautifully with Fabric, right? So again, OneLake is a single unified logical data lake for your whole organization. And a data lake processes large volumes of data from various sources. So like OneDrive, OneLake comes automatically with every Microsoft Fabric tenant and is designed to be the single place for all of your analytics data. OneLake is your one data lake for the entire organization. This is a pretty powerful statement if you want to understand Fabric as a product. And similar to how Office stores Word, Excel, and PowerPoint files in OneDrive, Fabric stores lake houses, warehouses, and other items in one lake. So in OneLake, you're going to have one folder, one parent folder that is your workspace folder. And when you go inside of that workspace folder, you will have other subfolders which can be your lake houses, can be your warehouses, or can be, any storage solution of that sort. And another thing that you need to be very clear over here is they can never be more than one. And if you have Fabric for your tenant, there can never be one lake. So in essence, for each Microsoft Fabric tenant for your organization, there's going to be one lake, one lake. That's the whole idea about it. And again, one lake, because it's a data lake, is built on top of Azure Data Lake Storage, right? So the product that implements the data lake and even the data lake house architecture, the underlying powerhouse, the storage layer is going to be your Azure Data Lake Storage. And this Azure Data Lake Storage, ADLS, is indeed a product. That's not an architecture. It's a product. It's a physical product. So with OneLake, you can have one copy of data for use with multiple analytical engines. And even if you notice, your data in OneLake can come from multiple areas. And these multiple areas can either be Azure, can either be AWS, Amazon Web Services, or even GCP. And you can sort of bring all of your data into one single place. That's going to be OneLake, and that's going to power your Fabric tenant. And just as I said in the previous slide, the analytical engine that you're going to be using doesn't really matter. So either, let's say, if you are someone who's comfortable working with Python, you can use Apache Spark to analyze or perform data analytics on your data that is stored in OneLake. If you're a SQL developer, if you're someone who's comfortable working with SQL, you can use analytical engines such as T-SQL or the same old school SQL. And if you are someone who's comfortable working with KQL for real-time analytics, you use KQL for real-time analytics to perform data manipulations and aggregations on your data that is stored in OneLake. And because of this powerful feature, if you are an absolute beginner, if you are just a SQL developer who doesn't even know what Apache Spark is, who doesn't even know what KQL is, all of you guys, be it data engineers, be it data scientists, ML engineers, or even KQL experts, all of these can work together in one single workspace, opening the room for collaboration. And that's what the power of Fabric is. Because it doesn't really matter what engine you're using. All that matters is the data that you will be using those analytical engines upon. That's the beauty about Fabric. And just as again, as I said, OneDrive stores all of your PowerPoints, all of your data, all of your Excel workbooks and Word documents as folders. And in the same way, your OneLake is going to store all of your lake houses, data warehouses, and even your workspaces as folders. And just to show you physically how this is happening, I've presented this slide for you. So there's something that's called as a uh, OneLake File Explorer, and that comes as a .msi extension. You can download that and fit that, embed that in your local file explorer for your device. And I already did that. So by doing that, I get to see how my OneLake for my Fabric tenant is structured. So if you notice over in this area, that's my OneLake Explorer, and this one is my OneDrive Explorer. And in the same manner, If you notice, all the workspaces that I've deployed in my Fabric tenant, be it course underscore workspace, uh, Medallion workspace, Prabjot workspace, WWI workspace, all these are managed as folders. And these are managed as folders just in the same way that your OneDrive manages your PowerPoint presentations, as you can see on the screen, as folders. So OneLake is nothing but OneDrive for all of your data. That's the beauty about OneLake. And if you go and let's say, if I were to click on this, double click on this Medallion underscore workspace, I deployed some lake houses and data warehouses inside of that workspace. And if I go inside of that folder, all of my lake houses and data warehouses are indeed managed as subfolders. So, just a bit of analogy, just to make sure that you guys are convinced that it's a OneDrive for all of your data. I presented this slide. So, just two statements that I'll like to present to you guys. Within a Fabric tenant, you can have multiple workspaces, and these workspaces, in fact, can have numerous lakehouses and data warehouses, as you can see on the screen. And all these workspaces are conceptually stored in OneLake, which is essentially an abstraction of ADLS, Azure Data Lake Storage. And each workspace corresponds to a folder in OneLake. And within these workspace folders, which act as the parent folders, you'll find the subfolders for the specific data artifacts like lake houses, files, etc. So over in the screen also you have subfolders. You have subfolders for lake house, data warehouse, and whatnot. And if you were to dig deep into, let's say, the lakehouse folder, you will find your files and tables. You will find your unstructured data and as well as your structured data in the form of Parquet files. And we just have two more slides to end this video. And that's this is yet another important slide. So with OneLake, which is essentially an Azure data lake storage, which stores or houses all of your organization's data, you can use Fabric as a product and even Azure Databricks as a product. And if you are speaking about Microsoft Fabric side of things, it's a software as a service. It's a no to low code platform, meaning it has ease of management, ease of use. It's economical because it runs on serverless clusters, and it also has something called as Copilot for Fabric, which is going to be an AI. Just as you have Copilot for Microsoft 365, you're going to have Copilot for Fabric, which will indeed make your work easier and reduce the learning curve. And this Fabric will be utilized for BI reporting, BI intelligence, and data analytics in general. It will be used for refining your data and sort of analyzing your data that is stored in OneLake. Whereas if I speak about Azure Databricks, it's a platform as a service, and it's going to be used to develop your AI and ML workloads and then publish them as REST API endpoints as consumable endpoints. So to be the leader in data and AI, you should know in depth how Fabric works. You should be comfortable with Fabric as well as comfortable with Azure Databricks, because Azure Databricks will be used to develop your AI and ML models and then publish those as endpoints. And if you notice, all of the data that's going to be used by Fabric and Databricks will be stored in OneLake. So your data becomes your single source of truth. And with development of AI workloads, it's pretty important to know where your data is stored and where it's going. And you do not want to run into the mishap of developing data silos. So, to be the leader in data and AI, I'll do a bit of self-marketing over here as well. You need to be pretty comfortable with Fabric and also Azure Databricks. And for that, I have two of my courses. The one that you are watching this video from, that's the and AI Microsoft Fabric course. And if you want to learn about AI and ML and how and sort of get an idea of how Fabric and Databricks work together, I highly suggest you go and purchase this course. It's another course in my catalog that's called as Data and AI Azure Databricks. So, to be the leader in data and AI and the way that things are moving forward, it's going to be pretty important that you learn Fabric and even Azure Databricks, which Fabric being SaaS platform and Databricks being PaaS platform. So that's pretty much it for the video. It was rather a long one, and in the end, I did a bit of self-marketing over here as well. But yeah, quite interesting, and I hope with this video I managed to clear things out for you and just an attempt to make or help you understand Microsoft Fabric better as a product. So that's pretty much it with this. Let's quickly move on to the next set of videos.